Hello, everybody, and welcome to the number one generative AI podcast in the world. So, I think we're growing, which is exciting. I think I said that last week, but just allow me to introduce myself. I'm Mark. I'm a software developer who doesn't actually work on AI, but I am what you call a self-described AI enthusiast, and we have Shashank, who is also not working on AI, but
I've started working on.
are you working on AI now?
Some stuff right now? After asking my team to get placed on some of the projects that I was interested in.
Oh, nice.
I got a flurry of projects all at once 2 weeks ago, and I'm trying to ramp up on all those different projects.
That is extremely exciting. So, anyways, we have the resident expert Shashank, who is the master at AI, and then I just, like to read the news articles and play around with AI in my free time. But anyways, so yeah, is there anything kind of new this week? Any new news? Well, I'll tell you one new news that not actually AI news, but I went to see the eclipse this past Monday.
That was a big deal, huh?
Yeah, flew to Ohio, watched the sun go dark, and saw a 360-degree sunset, which was really cool. So got there, got the little glasses to look at the partial eclipse, and then as soon as the total eclipse happened, you could just take the glasses off and just stare directly at the sun, and all that stared back was a black hole.
How long did you have the total eclipse?
3 minutes and 45 seconds.
Oh my god.
Yeah.
That's almost the max, right? I think the max was 4 minutes something.
Yeah, I think it was like 4:08 or something like that in Texas, right around that. But the entire event probably lasted, I think, around like 3 or 4 hours, something like that, because it takes a while for the moon to fully cover the sun. So as the moon is going across in front of the sun, you get more, it's called like a partial eclipse. And then once the moon fully covers the sun, you got that total eclipse. And then it's basically like somebody turned the lights off. It's really kind of a weird experience, because like the sun, it just like kind of gets like a little bit darker, but like darker in a weird way. The colors change a little bit, and then it's just like nighttime. Actually, I shouldn't even say nighttime. It's more like dusk, and you just stare all the way around, and then it's like the sunset. But normally how like the sun sets in the west, right? So you just kind of see it in one direction, and then you don't see the sunset the other way. Here, it's like all the way around 360 degrees, you see that sunset, which is a really weird experience. And then like as soon as it's over, it's like somebody turned the lights on.
And did it get really cold too?
Not really cold, a little bit cold. And there's lots of other like weird phenomena. So like the shadows, like if you hold up a certain item, the shadow is actually going to be in the shape of the partial eclipse. So if you have like a piece of paper, I actually used a thing to strain, when you strain like vegetables or like noodles, a colander. I think that's what they call it, a colander. So there's like these little tiny holes in the colander that are circles, and normally they're going to be circles when you look at the shadow. But if you hold the colander above the ground, the shadow is not circles, but it's like little crescents, like little C's, which is really wacky.
Yeah, I saw some videos of like the dappled sunlight shining through leaves, and anything that obstructs the sunlight turns it into little arcs instead of regular light.
Yeah, so really, really cool.
Very surreal.
Yeah.
I guess speaking of the eclipse, I started watching this Netflix show, Three Body Problem, and it talks about how challenging it is to model multiple bodies and the impact of the gravitational forces and predict their trajectory over a long period of time to figure out, where these bodies will be, maybe like 1,000 years in the future. And if you simplify our solar system as all the objects just...
So when you're saying like the three bodies, do you mean like three just things?
Yeah.
So like in our case, it'd be like the sun, the earth, and the moon.
Exactly.
Okay. Just
Exactly.
see like how they kind of interact with each other.
Exactly. So to forecast their positions 1,000 years in the future. Or like, this Netflix show was about 2 stars and a planet that was in a 2-star system. And to predict how the planet was going to move around and when it'll have its seasons and when it'll have night and day. And to predict that 1,000 years in the future, apparently that's a really hard problem because there's so many forces, not just within these 3 bodies, but, in some ways there's negligible amount of force with everything else in the solar system, in the universe, in the galaxy, that's all tugging on each other. And these imperceptible changes compound over time. So if you're extrapolating their positions far out in the future, these small, minor changes add up to a significant amount of force.
So that is a really interesting thing. Do you think that maybe AI, can we bring it back?
Yeah, that's where I was trying to go with this.
Yeah, okay.
I don't know. We haven't tried using these models. Well, I guess we have. We have protein folding, which is predicting shapes and how these things will assemble themselves. We have ray tracing, which is kind of like simplifying physics and building some heuristics to compute these things faster. So
ray tracing, isn't that used in like video games?
Yeah, exactly.
So isn't that like where like the light will like, if like you have like the light from the sun, like the light will go and like bounce off of different things.
Yeah.
And then you can use it for like drawing shadows and things.
Yeah, so light is very bouncy on colored surfaces that are not dark. Like a white piece of paper is white because it reflects all of the visible spectrum of light and maybe some invisible spectrums too. But if you open the window and let the sunlight in to your living room in your house, it's gonna bounce off of literally everything that is light colored and bounce multiple times until it illuminates every part that it can. So to simulate this in a video game, it's going to take like a lot of computation. It bounces on the couch, and from the couch it goes to the ceiling to like the nook under the table and so on. But I think NVIDIA did a lot of work a couple years ago to optimize this computation and simplify this calculation and make it really fast. So maybe we could apply something like this to physical simulations of 3D objects.
Yeah, actually, I was talking to somebody at one of our previous meetups. I think this was a few months ago at one of our larger meetups, and he was telling me that he was working on weather simulations. So apparently, weather simulations actually use some of like the world's most powerful supercomputers, and it's just like brute forcing a bunch of stuff. I don't exactly know how the weather simulation works, but apparently you need just like a lot of computing power to use that, because I think that there is just a lot of moving pieces. Like, oh, you've got the position of the moon, you've got the position of the sun, you've got the tilt of the earth, you've got the, I don't know, like the trees, are they in bloom, are they not in bloom? You have like clouds over here, you got clouds over there, you got like high pressure, low pressure. All these things all just need to be combined together, and they need to be able to try and predict like what is going to happen in a local area. And I think that's a really, really hard problem that you need lots of computers to do. And apparently he was telling me that there are some people working on like much lower powered AI models to be able to do weather prediction, where in the past you needed like super big computers. So maybe in the future we'll be able to predict, I don't know, the weather on our phone or something like that, which would be pretty neat.
I remember Google released some paper about way better weather prediction. And from what I remember, I think all they did was get more data with a higher granularity so that you could see how a storm or a cyclone or a hurricane was moving in a smaller patch of area, as opposed to like a more general, like on a country level. So if you abstract this out into like general machine learning, you get data, you train it for a bunch of time, and then you get a better prediction. So I think they just got more fine-grained data, and I assume more compute to make sense of that data.
Okay. Yeah, I would assume so. So that might be a paper to read potentially in the future. If we find anything, we'll post in the show notes, but don't count on it necessarily. So also, when I, speaking of like, the eclipse and whatnot, I was flying back from Ohio to come back to the Bay Area. And on the plane, there was a guy next to me who had these things, which I've never seen before. They were called the X Real AR glasses. So what they are is they are a pair of glasses that will kind of superimpose your phone or monitor onto your glasses. So think like, I don't know, it's kind of like the Vision Pro, but way cheaper and way smaller. But you have to like kind of wire it into the glasses, and then you can see just like whatever was on your monitor on the glasses. So before, like when you're on the plane, you have to kind of like have poor posture, crane your neck down, your neck hurts after a while. And I get this at work too. But then like, and also like you have the issue of like people seeing your monitor as well. So if you're working on something like, top secret, you don't necessarily want everybody looking at your screen. So it will go and then put the screen right in front of your face, and then it'll make your computer monitor black. So not like directly related to AI, but I saw that and it was just so cool. And I was looking online, it's only like $300.
Oh, that's really cheap.
Yeah. So,
and you said you got to try it?
Yeah, I tried it on.
What was the resolution like?
So that was one issue is I wear glasses typically, prescription glasses, because like my eyes are not the best. So it was a bit blurry for me. So for me, it just looked blurry. But I don't think that was because of the resolution of the thing. So I think that it'd be better if it had prescription glasses associated with it. And they were not really designed to have glasses go on top or underneath it. So like you wouldn't really be able to do it. But from what I could tell, it looked great. But
yeah, I'm taking a look at it on their website. So it's the X Real, and they have a bunch of different versions, Lite, Pro, whatnot. And it seems very similar to the Google Glass, just better build quality, maybe like a matte black finish on the outside. And in some ways, this seems exactly like the Apple Vision Pro's screen mirroring feature, where you put it on and look at your MacBook, and then it pops the screen out of your laptop and expands it into a bigger window that you can drag around and interact with it.
Yeah, but with this, there's only one screen, as far as I can tell. So it's just like one big screen in front of you. I don't know if you can do multiple screens. I only saw one. And actually, I take it back. Looking at their website, they do have the ability to have prescription glasses. So it looks like you can do that.
Yeah, it seems like the AI hardware space is picking up steam. We've had a bunch of companies. The Humane pin started by ex-Apple execs. I think that was the first on the scene. And then we got the Rabbit R1 earlier this year.
And that just came out recently. I think there was some reviews for that. What do you know about that, Shashank?
I don't know a whole lot. I have a friend who joined them. He's a big Apple fanboy. He loves hardware. He loves cutting edge tech. And he was like, this is the future. This is exciting. I want to go be a part of like a new operating system that is AI first and embracing this new paradigm of LLMs and generative models. I think it's really cool.
Yeah. So just to take a step back, for those that aren't familiar with the Humane pin, this is a new company that got created, as Shashank, as you mentioned, that
a couple of years ago, I think.
But even though it was a new company, or even though like a few years old, they've been just working on this new gadget, I guess you could say, that is AI first. So the idea is it's like a thing. It kind of is like maybe about the size of it's a square.
Maybe like half a phone,
Yeah, about half a
maybe
phone.
smaller.
Yeah, about that. Yeah, so yeah, about half of a phone. Like if you took an iPhone, cut it in half, and then there's a little pin on it, and then you could go and put this like kind of on your shirt, and then you can go, and then I think there's a camera on it where you can see like the world around you, and then there's also a microphone where you could talk to it, and I think it's in a certain sense it's kind of like wearing like one of these wearable devices like Alexa or like the Google Assistant, but this is, you know, arguably better. I think the reviews maybe said it wasn't, but I think it's similar to like wearing an assistant.
Yeah, exactly. I think they're embracing this new world of LLMs being able to do most of the stuff that you need for you, as opposed to you opening up your phone and tapping on a bunch of icons and taking action on your own. So this thing also has a little projector, and you can bring your palm up in front of the device, and it'll project some basic information like what's the weather, some navigation directions, who's calling you maybe. I'm not sure if it has that kind of feature, but yeah, so it's supposed to be a computer that you talk to and abstracts out all the other features that you would normally tap on the screen to do. And the
Because there is no screen, right?
there's no there's no screen except for the projector that projects onto your palm or another surface.
So it's just like a little like laser that like goes onto your palm.
Exactly.
So if you don't have like your palm out, like would it like project onto the wall in front of you or something? Like if I'm on like an airplane, do you think I could go and like, you know, see like the projection on the back of the seat?
I doubt it. Given that these things are so tiny, low powered, I don't think that kind of a projector would have enough power to go that far. So it's probably very near field.
Okay.
And talking about one of their recent competitors, the Rabbit, they took a slightly different approach. They have a screen, but it's a similar sized device. It's not something you stick on your shirt or lapel or something. You carry it around in your pocket along with your phone, and you talk to it, and you look at the little screen on the device. It also has a camera, and I think it runs some virtual machine somewhere that mimics an iOS or Android device, and it basically runs mobile apps somewhere else and allows you to log into your favorite applications, Uber, DoorDash, so you can take actions, order food, order a car, but it does it for you based on your natural language request.
Huh. Yeah, that's a really cool idea. So I don't know. I think that right now, these both all feel kind of like Gen 1 products. But let's say like a couple of years down the line, where do you think these products may be useful?
You know, honestly, I have no idea. I would need to put on like a UX designer or a product manager hat and try to visualize what it means to use a personal computing device. Because I think the biggest challenge for these companies is to figure out what to build. Like, we have the technology, we have cool stuff, we can build cool things, but how useful is it? I can literally do every single thing that these things do on my phone.
That's a really
arguably better.
That's a really good point. You know, I was actually talking with somebody at Apple the other day. I think she was like a product manager at Apple, and I said like, "Oh yeah, Apple's doing all this cool AI stuff." She's like, "No, Apple's not. We are like solving problems for customers. Like we are not like an AI company. We are a problem-solving company." And
I would agree with that.
I was like, "Oh yeah, that makes sense." It's like, I think that, you know, we get really caught up in just thinking about what can this technology do, and sometimes it's like in a certain sense, like a solution in search of a problem, as opposed to the other way around. So Like for example, like if I have this cool technology, I'm just kind of like looking for like a problem that I can solve with the technology, as opposed to like looking for like a problem that I can try to solve. So I think that, you know, that's a really important thing, to like actually think about like a real problem. So like, what are some like actual problems that like we have if we were going to put our product hat on for a second and let's just like speculate where we think that something like this could be useful in solving problems?
That's a tough question, man. You're putting me on the spot.
All right, all right. I've got one idea.
Okay, go.
Okay, so one thing that I think is an issue is, you know, I don't cook a lot. I don't cook a lot at all. But I think that,
Same.
you know, one problem that at least I have is like whenever I look at a recipe, I have to like, you know, go always like refer to like the recipe every time. Like I'm doing something and like I can't remember like always all the steps for everything. So like I think that like it'd be cool if I could wear like, you know, like a humane pin or something that like had a camera, like maybe not even looking at me, but maybe looking at like what I'm cooking, and it could be like, oh, like add this, or like, you know, maybe as I'm like chopping the onions, it's like, oh, chop it smaller. And then like it could say like, oh, like look at like as you're cooking, it's like, oh, not brown enough, make it like a little bit more brown, or like cook it a little longer. It's like, oh, that steak is raw, that'll kill you. So I think that, you know, if it could give you like real-time feedback about what you're doing, and I think that would actually be like generative AI, it could make all of us like Michelin star chefs, because like I think that like, well it could, because I mean, think about it, right? Like you know, I think like a lot of cooking is like getting like a feedback from like what you're doing. So like, you know, you taste the food, and then like based off of the taste you can like iterate. But if they could have like an AI model that's trained on like the top Michelin star chefs and see like exactly how they cook, then it's like, then they could be like, oh, well, this is like where you're cooking, which is like amateur level. This is how the Michelin star chef does it. And it's like, oh, this Michelin star chef, they cut their vegetables like this. They, you know, and then it's like, here's how you could change the knife to cut it in that exact same way. And it's like, oh, they use this amount of olive oil in the pan. And it's like, well, now you could use that same amount of olive oil. So it's like they could watch you as you're doing it and then give you real-time feedback to help you improve your cooking, and then just be really, really good.
I could see that. So the training data would be an expert chef wearing one of these pins, and the pin recording as much data as it can, seeing all the ingredients that they use, the proportions that they add, the temperature, maybe have like some kind of a thermal imaging camera.
Yeah.
So with all of that input, it'll just know exactly what the food is going to taste like even before it's ready.
Exactly.
And then guide you along the way.
Exactly. And it doesn't have to be a pen. It could be like the Apple Vision Pro, or, I mean, honestly, it could be your phone just like standing there. But like the problem is like with your phone is like you have to like put it up somewhere where it can like see you. You could like
put it on a stand somewhere, some kind of
stand, like some sort of like tripod or something. I guess that would maybe work. But I think it would be really good with some sort of like thing that's like actually on your body, whether it's on your face or on like your chest or something.
Vantage point.
Yeah, exactly. That I think that would like, you know, work. It could even be like some sort of, well, I was gonna say it could be like some sort of like smart pan or like smart cutting board or something like that. But then like you'd be limited in just like only the pan of the cutting board, unless maybe somebody would go and then like make like a whole entire set of like smart cooking tools, like smart pots and pans.
I've seen a lot of smart toasters around, where they have cameras, they have like temperature sensors, and also they come with meal kit subscriptions. So you just like put the meal inside and it'll cook everything exactly the right amount based on the recipe, and real-time feedback on the temperature of like the salmon that you're cooking maybe. So they have some level of that kind of automation, but I see what you're saying. So this seems very similar to a lot of the applications for AR with like Google Glass or the Apple Vision Pro, where you're getting feedback or instruction on any kind of task that you're trying to carry out in the real world. And cooking is like a fun consumer-based use case. But if you think about all these industrial workers working in like a factory or manufacturing production line, and there's like these super expensive machines that require a lot of training to operate and things like that. So if you put on one of these headsets and it can guide you into operating these machines and tools and whatnot, I think they're doing some of that.
Well, that's true. And it can even do things like inspect your work. So like if you're a Boeing engineer going and trying to like, screw some bolts into like a door, it could be like, oh, no, not tight enough. Maybe just do it a couple extra cranks. And then you could avoid any issues with like, doors flying off and stuff in the middle of the flight.
Yeah, you don't want doors flying off on a plane.
No, it's a bad look.
Yeah, so I can see these kinds of use cases making money and companies spending enough money on a product and selling it to enterprise customers. But for consumer, maybe we can. I mean, so we talked about two companies, Humane, Rabbit. There's a ton of other ones that have come out. There's like this Pebble-looking device that's called the Open Interpreter.
But like Pebble isn't like Pebble smartwatch?
No. It looks like a round, soft, spherical device.
Like a rock?
Kind of looks like a rock.
Wow.
No screen. I think it's just a voice interface. And it may connect with your computer and just be like a voice interface to interact with some model or something that's running on your computer and take actions remotely. And then we have like open source competitor for Humane. They call it Whomane, WHOMANE. So this space is pretty lively. There's a lot of different competitors. And if the price point comes down enough and a lot of customers especially like start collecting data and training models with these devices, I can see a cooking helper out in the next few months.
You think in the next few months?
6 months.
Really?
Because we have a ton of devices.
Yeah.
They're pretty cheap, $100 or a couple $100. The Humane pin is a little more expensive. I think it's like more than $500. But we have open source versions, and we have LLMs that are multimodal, that can look at videos, look at images, understand what you're doing, and give real-time feedback. So,
yeah, you're right. I think all the technology is there right now to build a cooking helper. I can't think of anything that we're missing. It's just not built yet.
It may not be very good with the stock models. You may need to fine-tune it.
I think it's pretty good. Well, I mean, yeah, now with the stock models, but I think like, with a little fine-tuning from the help of a Michelin star chef.
Sure.
I think that it could be really good.
Yeah.
Especially if it was limited to the number of recipes it could make.
Sure.
So you could like ensure that those are...
Get a lot of training data for like the basic recipes.
Yeah, like, I don't know, like a grilled cheese or something.
Sure. Grilled cheese, some pasta, make some cookies, baked goods.
Yeah, like a chocolate chip cookie.
Sure.
Yeah, whatever. That's what I'm looking for. I think that'd be exciting. So it's been a slow news week.
Yeah, this week. I mean, there have been a couple of shakeups in like the leaderships for some of these companies. It seems like Inflection, the company behind Pi, this is like a empathetic LLM, supposed to have high EQ, started by like the LinkedIn Reid Hoffman guy and former DeepMind folks, but their leadership left after getting a lot of funding from Microsoft.
Oh, wow.
And they joined Microsoft to lead their new Microsoft AI division, which is interesting to see Microsoft fund a company and then poach their executive team. And we have Stability. Their CEO left to, explore decentralized alternatives, I believe.
Interesting. Decentralized LLMs.
Let me confirm that.
Well, even before you confirm that, let's just speculate on why decentralized LLMs or would be fantastic. So, I think that I, for one, am okay with, these big companies training LLMs. I think that, all the power to them. If you want to have these big mega companies like Google or Microsoft training the LLMs, that's, fine. It's within their right to do so. They own the computers. They can train whatever they want, right? But I think that it would be nice if there could be a model that was trained, like you remember SETI? Is it SETI? Where they were looking for the aliens?
Search for extraterrestrial intelligence?
Yeah, exactly. Where they said, like, okay, everybody, you can go and rent, or like, not rent, but just like, give your computer.
Yeah, I was doing that for a while.
Yeah, like you can go
in like college or something, high school, college
exactly.
or something.
Yeah, you can go give your computer, and then we're
same thing with the protein folding challenge.
Yeah, exactly. You can go give your computer, and let it just run at night when you're not using it, and we'll use the power for that to go look for aliens. And then they do the same thing with protein folding. Actually, a lot of the folks who were initially involved in SETI, they were one of the very first Bitcoin miners, because they're like, yeah. So like I had a coworker who he was like super involved.
Very
in
similar
SETI.
problem.
Yeah, and then like he was like, oh, like I could not look for aliens, but I could get this like magical internet money. This was like back in 2009 or something like that.
Yeah,
I'll go and mine Bitcoin. I think he had like a few thousand Bitcoin, but then like at that time it was worth nothing. And I think he lost it, which was really unfortunate.
Oh.
But whatever. That's okay. I'm sure he's probably not too upset about it.
Yeah. I was thinking about the idea of decentralized LLMs a while back. But it's kind of hard to compete with these large data centers for price, speed, and just efficiency in general. So it's like you have these large models that you have to run, ideally like in the same memory space. So like that itself poses a challenge. And then the compute power to run these things, if you compare NVIDIA's latest and greatest to your local machine that you're going to use to run like a decentralized thing, it's not going to be nearly as fast. Not to mention, it's not going to be power efficient. So you're probably spending more in terms of electricity and stuff. I know it's like very minor on like an individual user basis, but
yeah, I think it's true. I don't think that the decentralized would be as good. But the thing is it's either one company or a million people all running this program. And if you have a million people each being like slightly less efficient, the million people still may be like greater than like, what one company could do at a single data center. So I think that is exciting. And then it's like, then it's our LLM. It's not like owned by somebody else, but it's owned by the collective good. And I think that's kind of cool.
Yeah, I think the benefit of decentralized is to work on models that may not align with like the core agenda and like the bureaucracy and red tape that large organizations have.
Right, because a lot of these large organizations have a lot of safety features, which I think is a good thing.
Yeah, it's a good thing.
But it has the potential of going awry.
A lot of limitations too.
Yeah. I remember, I think it was Ollama. They had somewhere on their website, they showed like a lot of the, there's like a page on there where it shows like, oh, this is a model which has a good response, and then here's a model with like a bad response. And it shows like how these like guardrails had like made like poor responses for LLMs. I don't know if you could find the page from Ollama. Oh, but anyways, basically, before we get to that, Ollama is a very interesting company. So Ollama actually announced at our meetup. I don't know if it was like when they first came out, but right when they came out initially, they said like, hello, we're Ollama. And they are now one of the largest projects on, I think they're like kind of the number one way of getting a model running locally on your computers. So the guys who came up with Ollama, they used to work at Docker. So Docker is a company that allows you to write your software once and then run anywhere. So basically, like there's a lot of, whenever you're running like a software program, there's oftentimes there's a lot of like effort that you have to do in order to get your software running on your computer.
Oh my God, that is the worst part.
Right. So like you have to like install like dependencies. So like, oh, I need to install Python. I need to install like this database. I need to make sure like, oh, it can't be Python 2, it has to be Python 3, or it can't be Python 3, it has to be Python 2, or this dependency is running on Python 2, this one runs on 3.
Honestly, it's not rocket science. It's just super tedious, but it's so hard.
Yeah. So Docker was invented where you could just kind of make a config file and then run all of your, just set up this config file, or what they call like a Docker container, and you run all of, you have all your dependencies set within this like enclosed environment that also runs like really fast. And so then you don't have to like actually go and like manually install all these different dependencies for your software. You can just go and then, use Docker and everything will just run. And well, you could do that with a virtual machine. Like this is like way lighter than a virtual machine. So it works really well. So they worked at Docker and they got a lot of familiarity working with that. And they're like, hey, like these AI models are super hard to set up. Why don't we just, I think they basically just Dockerize it. Like, let's just make this like, basically like run on Docker, or, whatever they did for their learning on Docker. And they're like, let's make it so we can run these open source LLM models super easily. So like in the past, you had to go on some esoteric websites to download these models, and now you can just like use Ollama. It's like one command line. Like you can set it up in like 5 minutes, and you can get like all these models running, and I think automatically updating too. So they had a so anyways, yeah, Ollama, super cool. But they had a blog post where they showed a bunch of examples of models with like guardrails and models without guardrails, and they showed like a lot of times like the models with the guardrails just responded like really poorly because of the guardrails. I don't know if you were able to find the blog post.
No, I couldn't find that one, but I remember this was like a pretty public news, especially with the earlier versions of GPT-4, where it kept getting progressively worse over time as they started adding more and more guardrails. And a lot of researchers kept talking about this, how restricting what the model can do, like, obviously makes it worse. It makes it safer in some ways, where you're not teaching people how to make bombs and makes illegal stuff and hack other people and do other illicit things. But, on the flip side, you ask it for something pretty basic, and it's like, no, sorry, I can't tell you that. It seems kind of sketchy, so I'm not going to do it.
Yeah. Also, one super cool thing about Ollama, just kind of as we're on the topic, they just, I think it was like a few weeks ago, maybe a month ago at this point, they came out with AMD support, which is super exciting. So for those that don't know, most of these large language models, they will only run on NVIDIA hardware, because NVIDIA makes this software called CUDA, and CUDA is a software that is proprietary. It will only run on NVIDIA hardware. But Ollama, those folks, they figured out how to run all these models that were originally designed for NVIDIA software. They now got it working. So if you have an AMD GPU, you can get your model running where it used to be NVIDIA. Now it can run on AMD, and that's huge.
Oh, I love it. Yeah, I think running these models locally is a pretty challenging problem. First, you need to get the models, and they provide a bunch of open source models, which is fantastic. Out of those models that are available, you have to figure out which ones can run well on your local machine. So it depends on how much RAM you have, how much processing power, what kind of GPU you have. Take all of that, get like the biggest model that you can run. And even with that, most of these models, I think they were run on the CPU when llama.cpp came out. It's like this open source tool to run these models, but it was early times, and all it could do was run on the CPU. And the CPU is not very good at running these models. It's great at doing a lot of things, but the GPUs are very good at running one specific thing, which is like parallelized operations. So they're very good at running these models. So Ollama allowed these models to run on your GPU. And from my understanding, it's actually not that hard to run inference or like generation on these GPUs.
So inference is just like using the model.
Yeah, just generate some output.
Yeah.
So all you need to do is try to map these operations that the LLM does, this large model, and map these operations onto the GPU and use the GPU to do these fancy matrix multiplications or ReLU or like whatever other fancy statistical mathematical operations that they do. Run it on the GPU so it's faster. It happens in parallel. So yeah, they've done a great job.
Yeah. So yeah, kudos to Ollama.
I don't know how this turned into an ad for Ollama, but they're pretty cool. I like them.
I don't know. they're really good. I don't even know how they make money because they just I think like everything's free, all open source.
I think there's a ton of companies that are jumping on this AI bandwagon and they still haven't figured out how to make money. They're just, exploring the space. I think that's partially the reason why Emad Mustak, the Stability founder, left, because they were burning through lots and lots of money and they were trying to figure out a monetization strategy, and it's hard.
Yeah.
Especially when you're giving out your tools for free.
That's true. Yeah, when you do the open source and you can't charge and you don't charge for your product, it is hard to make money. And
unless you're someone like Facebook, and then you don't really need to make that much money.
Well,
in the short term.
I mean, yeah, because they just sell ads, and just show it to billions of people.
Yeah.
Which I guess like maybe we're gonna see that in the future with like ads in your response. It's like, oh, you asked about this. Like, did you know that this product is for sale? And it's like,
oh my God, that is going to be a big field, I think. Once we start injecting ads into an LLM.
I mean, why? I think we will. That's going to happen.
I'm curious to see if there's any companies working on that. I don't think it would be that hard to do. So you just use the model to generate an output and then maybe have a simpler model just interject in between.
Yeah, just in relevant spots.
Yeah.
It's like you ask ChatGPT a question and then it's like, and then it has like a, an ad for dish soap or something.
Oh, that's interesting. And then you can give the model out for free because it's like ad supported.
Yeah, exactly. So then like you could have like your GPT-7 or whatever that's completely free with ads, or you can upgrade to the $20 a month one with no ads.
Oh, that's interesting.
Yeah. I mean, it's like Google. Well, actually, Google doesn't have a free or a paid version with no ads.
YouTube.
Yeah, it's like YouTube. That's right. Although I do actually pay for my search engine. I use Kagi, like Kagi. Fantastic search engine. I pay for it. They give me no money. I wish they did. If you guys are listening from Kagi, you could sponsor us. That'd be pretty cool. But anyways, yeah. Non-sponsored, just I use them. They're really good. I think the results aren't always better than Google, but there is no SEO nonsense on it. So like nobody's trying to optimize that. There is no search engine optimization. Like the results I find are pretty good, and I almost never actually switch over back to Google.
Interesting.
Yeah. So anyways,
yeah, I think that's all we have for today. I hope these open source models continue to grow, these open source tools continue to grow, and I hope they figure out some way to make money that is not ads.
We'll find out.
Yeah.
All right. Well, anyways, see you in the next one. Bye, everybody.
Until next time.